Welcome to problem 10 of the Computer Science 121 2013 Winter 2 Practice Final Exam. And this is designing DFAs. So we are going to design a DFA that takes as input a sequence of bits, 0 or 1, and accepts exactly those sequences that include at least 3 bits, of which at least 2 are zeros. So 0, 0, 0, 0, 0, 1, da da da, what is this saying? They should all be accepted. So 0, 0, 0 has at least 3 bits, and at least 2 are zeros. So 0, 0, 0, 0, 0, 1, it's got 2 zeros, 0, 1, 0 has got 2 zeros, 1, 0, 0 has 2 zeros, 1, 1, 0, 1, 0 is long enough and has 2 zeros, and this big long thing is long enough and has more than 2 zeros, so that's all good. 0, 0 should be rejected because it's too short. 1, 1, 0 doesn't have enough zeros. 1, 1, 1, 0, 1, 1, 1 doesn't have enough zeros. These are both too short and don't have enough zeros, and the empty string is too short and does not have enough zeros. Okay. Well, we can just start out and draw a state. Okay. So this is our start state. It's the empty string. We know the empty string should be rejected, so we're just going to leave it. And I'm going to keep track of everything that I think I might need to know. So I'm going to keep track of the number of bits. Okay, so just from my own notes, I'm going to have the number of bits on this side, and I'm going to have the number of zeros on this side. Because once I get to 2 or more zeros and 3 or more bits, I'm at my accepting state, and I'm done. Whatever else I get, I'm still going to be accepting. And that much I can see kind of right off the top. Okay. So, if I get a 0 here, then I've increased both my number of bits and my number of zeros. So I'm going to have 1 bit and 1 0 on a 0. And if I get a 1, then I'm going to increase my number of bits, but not my number of zeros. Okay. And if I get, I don't know, let's try this one because this will take us to an accepting state faster. If I get a 0 from here, then I'm going to have 2 bits and 2 1s. And you know what? I just want to get to 3 bits. And you know what? This was really 2 plus 1, so I don't really care. Zeros, that is, so I don't really care that I've got 3 zeros here. I just care that I have 2 or more because it says at least 2 zeros. Okay, so let's fill in the other things. If I get a 1 here, then I'm going to have number of bits goes up, number of zeros does not, and a 1 here, number of bits goes up, and I don't care if I get any higher than that, and number of zeros does not. Okay, so I'll start back up here again. If I get a 0, number of bits goes up, and number of 1s goes up, which is the same state as this. So, maybe they're different, but am I really going to go to the same place? Do I care if I go 1, 0 or 0, 1? I'm just counting the number of bits and the number of zeros, so I actually don't. So I'm going to erase this, and I'm going to have a 0 send me down, which is good, because as soon as possible I want to stop adding states to this machine. Okay, and if I get a 1 from here, then my number of bits goes up, but my number of zeros does not. And if I get a 1 from here, then my number of bits goes up, but my number of zeros does not. And if I get a 0 from here, then my number of bits goes up, and my number of zeros goes up. Okay, how about down here? Can I go across here? If I get a 1, my number of bits goes up, my number of zeros does not, so yep, I can. And if I get a 0, can I go down? Number of bits goes up. Oh, no, this should be 2 plus if this is... Did I do this right? So I started with 2 bits and at least 2 zeros, and I got a 1. Yeah, I should have at least 2 zeros here. Whew, okay. So that should work then. Oh, hey, and this should be an accepting state. I've got at least 3 bits, and I've got at least 2 zeros. These are actually the same accepting state. So hold on, let me erase this extra state that I put in here. because it's usually not a good idea to give yourself extra states. It's just extra work. So in fact, from this state on a 1 or a 0, I've got, yeah, on a 1 or a 0, I've got 3 plus bits and 2 plus zeros, and I really don't care that how many of the 3 plus bits are 1s and how many are zeros. And from here, on a 0, I also end up there. Okay. So let's keep going. Let's do one of these. Why don't I do this one? On a 1, I'm going to have yet more bits, but this still says 3 plus and no more zeros, so this doesn't really help me. I already know I have enough bits. On a 0, I'm going to have 3 plus bits and 1 0, 3 plus and 1. But that's the same as this one, so I can actually get rid of that. And I can just have the 0 send me over this way. Okay. Oh, what have I not done? I've done this one, and this one, and this one, and this one. I've done this one, and this one. I've not done this one. I have done this one. I've not done this one. So these are my 2 that I still have left to go. I'm just going to highlight them so I remember to come back to them. Okay. So I'll do this one first. So I'm going to erase the highlighting I just put down here. And on a 1, I've got 3 plus bits. I've still got 1 0. I don't care about that. On a 1, I just want to stay where I am. And there's no change. I've still got 3 plus bits. I still only have 1 0. On a 0, I've got 3 plus bits and 2 plus zeros, because I only care up to 2, and I know that that is my accepting state. So I'm going to draw my arrow down there. So that just leaves me with this state, which is good. Hopefully I can close it off here. So from this state, if I get a 1, I've still got at least 3 bits, at least 2 zeros. What happened to my arrow there? There we go. If I get a 0, I've still got at least 3 bits and at least 2 zeros. So this is actually sort of a capturing state. Once I get here, I'm just going to stay here. So this ought to be a DFA that does what I want. It's got kind of a neat structure, sort of slants down to the left there. Okay. By the way, I worked through this problem separately now, and I've thought of a better way to represent things so that the DFA has fewer states, but it's not critical that you get the DFA with the fewest states. We don't want gigantic, difficult-to-read DFAs, but even if you had done 0, 0, 1, 0, 2, 0, 3, 0, 1, 1, 2, 1, 3, 1, 2, 2, 3, 2, and then had 3, 2 down here. So even if you'd had like sort of this full triangle, that still wouldn't be a lot of states. Even if you'd had this full square here, so you'd done 0, 1, 2, 3 across and 0, 1, 2, 3 down and put everything in here, that wouldn't be that many states, especially because it would be a nice pattern. So don't kill yourself trying to make the smallest ever DFA, but do try to make it make sense to you, and check as you go to make sure that you reuse states if possible. So now I want a regular expression with, I want at least 3 bits, at least, this is just notes for myself, 2 zeros. At least 3 bits is easy. If you were just writing a regular expression that was at least 3 bits, you could just say, oh, well, I want a 0 and 1, a 0 and 1, or 1, a 0 or a 1, and then any number of bits after that. Right. The trouble is that these 3 bits, we kind of need at least 2 of those bits to be zeros. And the trouble is it doesn't have to be 2 zeros in the first 3 bits, right? Like this ought to work as well. And so we can't even just try to figure out a way to say that there's 2 in here. So let's work on at least 2 zeros first of all. So that would be like anything, 0, 1, star, and then a 0, and then anything, and then another 0, and then anything. Right, so this would give us at least 2 zeros, greater than or equal to 2 zeros. So we need one additional bit beyond that. So we need at least 1 bit in one of these ranges, but we don't know which. I mean, maybe it's 2 zeros in a row here, maybe it's not 2 zeros in a row. So there's 3 possible places that our extra bit can be, and I'm just gonna write that out. I'm gonna write out the 3 possibilities So it could be our extra bit is here, or it could be that our extra bit is here, or it could be that our extra bit is here. So I will write that out, 0, 1, plus, and now all of a sudden my extra bit is right at the start, because I've got at least 1, 0, or 1 there. Okay. Or, it might not be that, maybe my extra bit is in the middle. Or it might not be that. Maybe my extra bit is on the right. Oop, sorry, kind of ran out of space there. So there we go. There's my extra bit on the right. So this is my answer right here. And all the stuff up here is just scratch work. I'm just going to lightly cross it out so I don't get myself confused later on. Scratch. Work. Okay. Ooh, I probably shouldn't use a star for that, should I? How about I just say answer? Okay, so this says I've got at least 3 bits because there's 1 here, 1 there, 1 there. There's 1 here, 1 there, 1 there. There is 1 here, 1 there, and 1 there. And then I've got at least 2 zeros. There's 2 zeros in each of these. And are these all the ways that I can have 3 bits around these 2 zeros? Yeah, the extra bit can be before, or it can be in the middle, or it can be at the end. So that takes care of it.